So in the last lecture, we had seen various operations of languages, right? We had seen what do you mean by a language, the formal definition of a language, and then how do we perform concatenation, okay, of two particular languages. We had also seen something called as, what was that? Yep, we had seen concatenation, then we had seen the various set operations, also the clean star property. What does that mean? Okay, when to include epsilon and when not. What do you mean by an empty set, etc., etc. Okay, all that we had seen, and then we had taken two examples on representing a particular language. Okay, so now let us see. Then I think we had also,
Excuse me, ma'am.
yes.
Ma'am, you are not audible, properly audible.
Am I audible now?
Yes, ma'am.
Okay, so yesterday we had seen various set operations, and we had also seen what do you mean by clean star, what is that, and what's the definition of an empty set. Yes, we had seen that in the last lecture. And we had started with something called as binary representation. Yes,
Yes, ma'am.
of a particular of a so how the information is represented in binary format, and how do we actually proceed with that. Just give me 2 minutes. Okay, so we had seen the binary representation of a particular number, and how do we perform various operations like addition. Okay, on that we had seen addition in the last lecture. So and there was a concept which was called as carry. For that, yes, for that, what was the main reason to generate a carry? Yes.
To add two ones in binary addition.
Yes, to add ones in binary addition. Now, and that was the reason was also given. There were certain rules, right? There were certain rules which shows how to actually proceed with addition and how to generate a carry, because 1 plus 1 cannot be 2 in binary addition. It has to be 0. So we are interested in the information which is either 0 or it should be 1. Okay, it cannot be more than that. So our mathematical calculus and this is totally different. Okay, so let me just recollect that. What we had done is we had seen the addition of two binary numbers. For example, if it was 1000101, then another string of binary numbers was 10110, right? This was addition. We were supposed to perform addition over here, and we got the result as tell me 110. Yep, 0 1 0, and here again you have a carry, so 1. This is your final output, right? This was how it was supposed to look. Okay, now in basically in languages, in regular languages, there is a concept, or over here we have something called as states. Okay, now what is the formal definition of a state? See, states are what? States are basically, there are two types of states. We have initial state. Okay, initial state, or it is also called as the starting state. Okay, initial state, and it is represented by a circle like this. And I can denote it as, for example, q0, q0. Okay, q0, it denotes the initial state. Similarly, we have another type of state which is called as final state, right? We have a final state, and it is represented by double circle. Now, when we draw a now we will see some important topic. I hope I'm audible, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, yes. Now over here, see there. Just remember that there are two types of states: initial state and final state. Okay, initial state and final state are always represented by a circle. Okay, and you denote that by q naught. Is q naught, it says that it's a initial state, whereas q final state can be anything. It can be q1, q2, q3, etc., etc. So for example, I'm taking here as qf. Okay, my final state. So this is how you represent a particular state. Okay, and we are going to use these states to generate a state transition diagram. Okay, state transition diagram. Now there is a basic transition diagram, and there can be a regular language, or we can say that regular formal automata diagram. For that we require this final state. Okay, now we will see something called as state transition diagram, and we will also see some of the concept like state transition table, etc. Okay, now what is that? Let us have a look at it one by one. Oh,
Excuse me, ma'am.
yes.
Ma'am, have we covered graphs and trees?
Graphs and trees, that's just a theoretical concept. I'll just explain. I mean, it's not of a more weightage. Yeah, we don't have to look into numericals and all in that. Okay, if you want an overview of that, we can just finish it off in 10 minutes by using PPTs. Okay.
Yes, ma'am.
Okay. Now comes state state diagram. Okay, state diagram. Over here, see, I am drawing a diagram over here that is called a state diagram. I have two states. Okay, for example, I have two states, Q naught and Q1. Q naught and Q1. Okay, this is how you represent a state diagram. But you may have a question here, and this Q naught is a initial state. Initial means what? The actual work, or the actual language is passed through this particular state, or the information starts processing by this at this particular state. So that's why it is called as an initial state. Okay. Now let us have a look here. For example, I have two states, q naught and q1. Okay, q naught and q1. Now let's take our binary value, binary string values. What were the values over here? You were having 100101. You had 1011 1 0. Okay, this were the strings, na? These were the two binary strings which I had given you, and I asked you to perform addition, binary addition of these two values.
Yes.
Yes, any questions?
No, ma'am.
Yes or no? Okay. So, yeah. So try to perform the addition. So this was our answer. Now, what we had got. This was our answer. Okay. This was our final answer. Now let us represent that in terms of an initial state and a final state. Okay. Initial state and a final state. So the initial state, it begins at Q naught. Your Q naught is the initial state, and Q1 is considered as a final state. Now you may be having you may be having a question here, why it is not represented in a double circle form, right? So there's a, because just remember what I'm explaining over here, it's a basic transition diagram. But when we move further, and when I say that I want to draw a formal state diagram or a state transition diagram, over there I will use the concept of something called as final state in this way. Double circle, I will show it in state. Remember this, I will show it in transition state transition diagram. But here I'm just showing you the basic state diagram. Okay, that's why. So just understand this. Q naught is your initial state, Q1 is your final state. Okay, now have a look over here. How many inputs do we have here? What are my inputs here? Yes, guys, what are my inputs?
Two inputs.
Okay, this I have two inputs, 100 101 and 10 11 10. I have two inputs and I have one output, right? I have two inputs and I have one output. Getting? Now I have to draw a state diagram for this given operation or for the addition which we had performed. Okay, Q naught is our initial state. So over here, check from this side, right? Right to left, not left to right. Okay, you always perform operations from right to left. So check the rightmost side over here. 1 plus 0. Are you getting this, all of you? I want to hear your voices. Just unmute and say yes.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, very good, thank you. Okay, so you have 1 plus 0. Okay, this is what this sorry this is your final. We give me some time. Okay. Okay. No problem. We'll start. Okay, this were our two inputs. Okay, 1 0 1 1 1 0. My answer is
Ma'am,
1
your screen is
1. Okay, just 1 minute. Is it visible now, guys?
Yes, ma'am.
Let's begin. Okay. So let's begin from here. Okay, 1 0 0. This was answer. 0. Write it down. 0 1 0 1. This was my this I have two inputs here and I have one output over here. Okay, I have two inputs and an output, and I'm interested in showing that in form of a state diagram. I have two states over here. My initial state is Q naught and my final state is Q1. Okay. What are my inputs? And one more thing, Q naught is your initial state. So you always show that by an arrow like this. Okay. Show that it's a initial state, right? So always remember that your initial state always begins with the arrow like this. So it indicates that this is a start state or an initial state, right? So that is how it's done. So this Q naught is our initial state. Q naught is our initial state and Q1 is the final state. Now check the input here, 1 plus 0. Okay, we have two inputs, adding two inputs, 1 and 0, right? 1 plus 0 gives you 1. But initially we are in the initial state, right? At start, we have not moved further. We have to begin with our initial state. We have to start with our initial state. So over here, I will show what? I will show the transition, right? I'll show the transition like this. I'll show the transition like this, okay, with an arrow like this. It means that it indicates that I am still in my initial state, okay? And what are my inputs? My two inputs are 1, 0. Yes, my two inputs are 1, 0. So I will write 1, 0 and followed by a output. What is my output I'm getting here? 1. So for this, remember like this. Okay, you have this initial state Q naught, for example, okay, or any state like this. First, you have to write the input values slash output value. This is the syntax for drawing or representing a state diagram. Okay, you have to show the state and then you have to show the transition followed by two values, input slash output. Now check that in this diagram. Q naught is our initial state. I'm performing addition of two binary numbers, 1 plus 0. 1 and 0 are my input here. Relate that. 1 and 0 are my input. That's why I'm writing 1, 0 slash what's my output? Output is 1. That's why I'm writing 1 again. Now check the addition again. You have two inputs, 0, 1. So have we moved further? No, na? We have not yet moved further, right? To the next state, final state. Yes, there should be a lot of questions here. Okay, a
And
lot of
what's the
questions should.
final state?
Very good. See, yeah, what?
What is the final state? Like, how is it different? Like, what's gonna
Yes,
change in the final state?
very good, very good. I was about to say that only. You should have that question in your mind. So why not we moved from Q naught to Q1? Why just we showed the transition on Q naught? Yeah, yes, this is a big question. Now why? See, check the output here. Okay, initially you always begin with a initial state. Okay, the output here is 1. Okay, so then over there you have to show that particular state is, you have to show that particular output or the particular value is in the same state. Why? Because there is no change in the value. There is no change in the value, right? Initially you are getting 1, so we have to show as it is in Q naught in your initial state. Now check another value. Here also you're getting 1, so it will be in the same state. The moment it the moment it performs transition. Now what is transition? The moment it perform transition means change in value of output. Okay, change in value of output. Okay, the moment it performs transition, it changes its state. Getting?
Yes,
Now,
ma'am.
see here, initially we began with Q naught as our initial state. Then we check the inputs, 1, 0. Okay, 1, 0. Since we do not have any other value on the rightmost side, our first value itself is 1. That's why we have to show the transition in the Q naught state itself. We don't have another value here to compare it with or check whether it's changing or not, right? Initially we are getting 1, so that's why we have to show that in Q naught itself. Okay, now check another one. Another input is 0, 1. Our next, we change our location pointer, right? We will be changing our location pointer. We were here, we were in this location. Now we have changed our position and we have moved to this pointer now. Okay, okay, shifted from here till here. Now check the two inputs, 0, 1. Okay, 0, 1, and we are is the value changing here? No, right?
No.
The value is 1 itself. So it means that the particular transition remains in the same state. The transition remains in the same state. So I'm again showing it in this form. I'm drawing an arrow here. I'm showing that the value or the transition remains in the same state. These arrows are called as the transitions. Okay, these are the transitions. Transitions means change in the value. Okay, or the it is we also always require it to represent the input and output. Okay. Now see here. So again, 0, 1. We have two inputs. Now we have to represent that in this form. We have two inputs, 0, 1. So I am writing 0, 1. These are the inputs, right? Slash, what is my output? 0. Sorry, this is my output. Now what was the output I got it?
One.
It was 1. So I'll
One.
write 1. So it is in the same state. Okay. Now there's a twist over here. Now tell me, what should we do? 1 plus 1 gives you 0. So there is a transition, change in the value of a particular state. There is a change here, right? Transition which
Yes,
is
ma'am.
happening. Change in value. There is a change in value. So now, then only then we can say that the transaction moves from one state to another state. Okay. So now it will move from Q0 to, it will go to Q1 because the value of the output has changed. Okay, there is a transition. So now we can represent that Q0 goes, the value goes, the transaction we can show like from Q0 to Q1. And my input over here is, what is my input? 1, 1. My input is 1, 1, and my output is 0. Is this much clear, all of you?
Yes, ma'am.
N- Okay. Now, now check another value, 0, 1. So now we cannot move here. We are here now. We have changed our location, right? Okay.
Yes, ma'am.
We have changed our location. Now we are not in Q0. We are in Q1 because we have showed this transition 1, 1 slash 0. So we are in Q1. So we will start from Q1 itself. Okay. Now check. Next value we are getting is 0, 1. Okay. 0, 1 gives you 0. So is there a change in value over
No,
here?
ma'am.
There is no change. So what does that mean? It remains in the same state. It remains, the transaction or the transition remains in the same state. So I will show that like this. Okay. My values are 0, 1. Inputs are 0, 1, and my output is 0. I am not changing the state because I'm not getting the change in output. Okay. Now again we will change our location over here. Okay. We have changed our location over here. Okay, over here now. What are my inputs? 0, 0. And my output is 1. So yes, there is a change in the, here we are getting change in output. Yep. Change in output we are getting. There is a transition which takes place from 0 to 1. We are getting 1 now. Yeah. So now we will move to which state now?
Q not.
Very good. Aha. Okay. We are moving to Q naught now. We are moving to Q naught because the value of my output is changing from 0 to 1. So I will move to Q naught, and my inputs here are, what are my inputs here? 0, 0. It gives me 1. Now my location pointer changes again. Yes. What's my answer here? Yes.
Then it's gonna
What
go
will I
back
do?
to. It's gonna go back to Q1.
Okay. We again have to go back to
Q1.
Q1, right? So we are here now. We are at Q naught. Our next location is 1, 1, right? 1, 1 is giving you 0. The value is changing, and we are in Q naught state. We have to go to Q1. So do we have to show the transition again? The question might arise, but no, we don't have to because it is repeated. Okay. From Q naught, we have to move on, or we have to shift to Q1 over here. But we already have the values with the same input and output. Getting this? We
Yes, ma'am.
previously had it, right? 1, 1 input. My input was 1, 1, and my output was 0. Check the values here. 1, 1, 0. It is repeating, so we don't have to show repeated transitions. So it means we have reached here now. Okay. Now again, 1, 1 gives you 0. Is there a change? 1 1 gives you 0. That was the same thing. Okay, and what was our final answer now? I'm getting a carry as 1. Carry is 1, right? Here, this one.
Yes, ma'am.
My carry is 1. So we don't have to show the carry. We just write here, and we write a statement here. Carry is in final state. We can write a statement here that carry is still in the final state. Carry is in the final state. That's it. This is how you draw a particular state diagram. Okay, this is how you draw a state diagram. Okay, now let me just give you one example and you try to draw it. Okay, we will see one more example over here. Okay, is this clear this much?
Yes, ma'am.
Okay, now one more thing here is once you are done with this, you have to write it. You have to write the inputs here. What will you write it? Inputs, my inputs are, start with the initial state. My inputs are 0
1
0
0
0 0 0 1 1 0. What else?
1 1
Very good. 1 1. And one more thing. You have 1 0. And again, do we have 1 1 in Q? No, no, yeah. Overall, we are saying, right? Correct. So 0 0 0 1 1 0 and 1 1. And what else? 0 1 we have already written here. Okay, 0 0 is also there. Okay, so these are the inputs. This many inputs we have. And the output we are getting is, what's my output? Output is either 0 or it is 1. Okay, I'm getting the output in the form of 0 and 1. Check everywhere. Check in the states here. In the first transition, I'm getting output as 1. Second, I'm getting 1. Third, over here also I'm getting 0 0. So output is everywhere, the output is in the form of 0 and 1. So this is how you represent a particular operation in the form of a state diagram. Okay, now I'll just give you one example and you uh,
Ma'am,
try to construct. Yes.
ma'am, I have a query over here.
Yeah, sure, you can ask.
Ma'am, over here, when we are adding 1 plus 1, it is showing chain. So we are shifting from Q0 to Q1,
Yes.
right? When we are adding 0 plus 1, then too
Yes.
it is showing change. So why we
Where?
are,
0 plus 1 which change?
ma'am,
0.
over,
This you're saying, right? Over here, this one, na?
yes, ma'am.
Ah. So see here. Initially, we are in the state Q naught. Okay. The value I'm getting is 1. Again, I am changing the location pointer and I'm getting the output as 1. So I'm still in Q naught. Okay. But but the moment you shifted from one state to another state, I mean, you are shifting from Q naught to Q1 now from at this location at 0, right? Because there was a change in output 0. We got the output as 0. That's why we changed our state to Q1, right?
And ma'am,
And
means if
one
we
more
are having, ma'am, means
from,
if we are having the output 1 1, we have to put it in Q0. And
no,
if we are
nothing like
having
that.
out, no, no,
No, no,
ma'am,
no, no.
in
Yeah,
this
yeah.
case,
See,
I'm
see.
saying.
Yeah, yeah.
Uh,
So in this case, I'm changing my position to here, and I'm get the value of my output is changing. That's why I have changed my state here, Q naught. Now you have a question here that here also we are getting 0. So why not we changed it? No, the answer here is, I mean, you have left this state now. Getting? You have
Ma'am,
already
I
left.
understood.
Understood? Because you left this
Yes,
state
ma'am.
now and you are in state Q1. Now you have to check the values with respect to Q1. You forget about that state now. You are interested in Q1 because you are present in that.
Actually, I was considering the input state and not the
Okay,
output state. That's why.
okay, yeah, I got it. Okay, getting?
Uh,
So you have to consider your present state and forget about your previous state, okay? That's why you are still in Q1 and you are getting the output as 0. Again, when I change the location pointer, I'm getting the same value of output as 0. That's why I'm not changing the state and I'm present in my Q1 state itself. That's why this 0 1 will gives you 0. That still remains in Q1. But over here, I got the output as 1. It has changed from 0 to 1. Then I move from Q1 to Q 0. This is what we do. Now, let me give you a question. Okay, perform addition of two binary numbers. Perform addition of two binary numbers. Okay, 1011. This is your first number, and our second number is 0101. Okay, these are the two numbers or two binary values I am giving to you, and I'm asking you to draw that state transitions, not transition, draw a state diagram for the same. Okay, addition, perform addition of binary numbers, perform addition of binary numbers. Okay, so what will be my answer here? 1 plus 1 will gives you, it gives you 0, right?
Yes, ma'am.
One carry is generated. Then again 1 plus 0 plus 1,
Zero
it's
carry one.
again giving me what?
Zero carry one.
0 carry 1, 1 plus
Then
0 plus 1
again
plus
zero
1,
one carry one.
0 carry
Zero
1, 1 1 0
then
1
zero one
0, right?
carry one.
And carry 1. This is your answer. And what are my inputs? This two are my input and my output is this. Now how will you draw a state diagram for that? Yes, how will you draw that? We'll draw
Ma'am,
it
first
here.
we will take two states, Q0
Very good.
and Q1.
Suppose I'm taking two states, Q naught and Q1. Okay. I'm checking my two inputs, 1, 1. Initially, I'm where? Initially, I'm present in my initial state itself.
Q2
I'm here.
state.
I'm here. And my two inputs are 1, 1 and my output is 0. So I don't have any choice because that is my start state. I have to be there. So that I can write 1, 1 gives me 0. Then again, I'm changing my location pointer from here to here. Okay, 1 plus 0 gives you 0. Is my value of output changing? No, it's not changing. So again, I'm showing the transition over here and I'm writing 1 0 is giving me 0. Then check another one. Here also 0 1, it's giving me 0, right? The value of output is not changing. Getting this over here, there is no change in the output. It's same. So that means what? We have to show that many numbers of transitions on the same state. So here again we have 0 1. So 0 1 gives you 0. Again you have 1 0. Do we have to write that again? No, because we already have the same transition like 1 0. We already have it. So one more rule over here is you have to eliminate redundancy of transitions. Redundancy should be avoided. Okay, redundancy should be avoided. It is avoided. It means transitions of same values cannot be shown on the state transition diagram. So 1 0 is giving me 0, but I'm already having that transition, so I'm not showing it. Getting? And then what is my carry generated? Where is my
Fine.
carry? Carry remains in Q naught itself, right? Carry remains in
Yes.
Q naught itself. Okay. Now
Okay,
tell
so if
me,
there is not a
have
transition,
we
then it will
reached?
remain there.
Yes. Now tell me, have we reached the final state? Yes or no? This is a question for you, right? Have we reached the final state? No, na? In this question,
No, ma'am.
everywhere, every
No, ma'am.
transition, yes, every transition, it's starting from Q naught and ending at Q naught. We have not reached the final state. So such condition can also arise. So here, over here, you can write the solution at it does not reach the final state. So that's why it's called as it becomes a dead state. Dead state. It means it is not reaching final state. Okay, this might also happen. So you just have to follow the logic, you just have to perform your answer solution very well, and then you have to represent that in the form of a state diagram. Okay, so eventually the output can be anything. So in our second case, it is not reaching the final state, that's why it's going in the dead state, and we have to write a comment over there. Okay, so this was about that. Now, let us see some other example. Just 2 minutes. Okay, now the definition of our finite state automaton. We will finally shift to our finite state automaton. What is that? We will see that in detail. Okay, we still have few minutes left. So over here, let's start with another one. Okay, now our main topic comes. Okay, we had completed, we had seen state diagram and all. Now I'm interested in my main topic, that is finite finite state. What is that? FSA, finite state automaton. Finite state automaton. So the definition goes in this way. You can write down the definition. Okay, make a note. So FSA or finite state automaton is also called as a recognizer. It is called as a recognizer or acceptor. A recognizer or acceptor. Okay, it is called as a recognizer or acceptor. So FSM can be designed such as it accepts. Okay, FSM can be designed such as it accepts subset of sigma star. What do you mean by sigma star? Set of all strings. Sigma star is set of all strings. Set of all strings, that's called as sigma star. So FSA, it is designed such that it accepts the subset of sigma star. The subset of sigma star, for example, where sigma is equal to a comma b. Sigma is equal to a comma b, right? This is the formal definition of a FSA, finite state automaton, which says that FSA or FSM, okay, it's the same thing. So in some contexts, it's also stated as finite state machine. Okay, finite state machine. So it can be FSA, finite state acceptor, or it can be finite state machine. Okay, and what is that machine? It acts as a acceptor or recognizer. Okay, it acts as an acceptor or recognizer. Getting? Okay, now where is that used and why that is useful? We'll see that in more details. Okay. So consider a transition diagram. We have a transition diagram over here. For example, this. I'm having 4 states. Okay. Now consider I'm having 4 states and my final state. This is my final state. Okay. This one. Okay. This is my initial state. Okay. Q naught. This is my initial state. Q1, one more state. Q2 is my final state, and I also have one more state D here. Q naught is my initial. I'm also showing the transitions. Okay, this diagram is given to you. Now you have to construct a state transition diagram, or we'll see how that works. Okay. Over here, like A, B, again I'm writing A, again I'm writing A, then again I'm writing, and I also have one more transition B over here. Okay, and this is my final state. So this is my state transition diagram. Okay, this is my state transition diagram. Okay, now suppose this just draw this diagram. Suppose this diagram or state transition diagram is given to you. Now, what's the difference between a state diagram and a state transition diagram? As I had also shown in the previous example, in your state diagram, you can just represent a particular. This is your start, okay, and this is your final state. Final state can be represented in the form of a single circle, but whereas in your this thing finite state automaton, you always represent your final state with a double circle. Okay, you always represent that, only that is the difference. Okay, this is FSA, finite state automaton or finite state machine. Okay, now a question comes to you. Given this diagram, this state transition diagram is given to you, and you have to compute state sequence. Okay, question number 1. Compute compute the state sequence. Compute the state sequence. Okay, compute the state sequence here. Okay, how will you do? And I'm giving you a string. I'm giving you a string as AAABB. This string is given to you, right? AAABB. Let's see this properly. Okay, this question is given to you, and you are supposed to compute the state sequence. How will you draw the state sequence here? See, I'm having the input. This input will be given to you. Okay, I am having the input as AAABB. These are my input. Okay, and my state sequence will be like this. Initially, you have to draw it in this way. Okay, state sequence. Initially, I am in my Q naught state. Q naught is my initial state. Okay, now check. Okay, now check the diagram. Are you getting, guys?
Yes, ma'am.
Okay, very good. Now check the diagram over here. In the diagram, just see, you have to check in this way. Q naught A. When do you get the here? And see, one more thing to notice here is that here you don't have to represent the input. You just have one output state. Okay, you don't have to represent the input and output. This is the difference between the state diagram and state transition diagram. A big major difference. Yeah, in the state diagram we had input slash output. We were showing both input and output, but in our state transition diagram, state in our state transition in our state transition diagram, we are not showing the input. We are only interested in the output. That's why we are not having two values here. We are just having one value. Now check. When Q naught 0 gives you A, when does Q naught gives me A? When it reaches state
Transitions to
Q1.
Q1.
Very good. When it reaches to state Q1, it gives me A. Yep. So that's why I can write it over here. Q1. Okay, like this. It goes in this way. Q naught A. Okay, when does Q naught gives A? A is my output, right? When Q naught gives A, when it reaches to state Q1 over here. Q naught gives A when it reaches to state Q1. So I'm writing like that. Again, you check now. Q1A. Okay, when does gives me, when Q1 gives me A?
On
When
Q1
it is,
only.
oh, very good. When it is on Q1 itself. Now again, Q1A in Q1 itself, right? We are starting a transition from Q1, right? And when is Q1 giving A? When it is in the same state, Q1 itself. So again, I'll have to write Q1 over here, right? Like this, and it goes like this. Now check Q1B. When does Q1 gives me B?
Q2.
On Q2, when it reaches Q2, right? By reaching Q2, this Q1 is giving me the value of output as B. So I'll write the state here Q2. Okay. Now, now check Q2B. When does Q2 gives B? Okay, when Q2 gives B?
On Q2 only.
On Q2 itself. On Q2 itself. When it is in Q2 itself. Okay. So this is what, now we have finished traversing. We have finished the traversing the input string here. We don't have any values left. So we will stop here. We will stop here. Okay, and Q2 is my, so I also check one more thing, guys. Is it reaching the final state now?
Yes, ma'am.
Yes, it is reaching the final state because my Q2 is the final state. Q2 is the final state. So we can say that, just write one line here, that the string, or yes, that's what we can say, the string, the input string, the input string triple A double B is accepted by the finite state automaton. This is what my solution is. So this is the way, given a state transition diagram and an input string, you have to compute a state sequence and show the justification whether the string is accepted or not accepted by the finite state automaton. Why? Because the main job of finite state automaton is to accept, right? It is also called as an acceptor, right? FSA is also called as an acceptor or recognizer. The definition says that. So you will be given such state transition diagrams with the input string, and you will be asked to see or to check if this finite state automaton, I mean, whether this input string is accepted by FSA or not. So our final solution is yes, since it is reaching the final state, since the last value is reaching the final state, we can say that the input string triple A double B is accepted by the finite state automaton. So this is our solution. Okay. So anything else, guys? I think we will stop here. I will download your attendance. But if you have any queries, please ask it. No, I guess no.
No, ma'am.
Okay. Okay, guys. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Wait a minute. Let me just